What's up, everybody? Welcome to Earth Science. I'm back here hanging out with my rocks because it's time to start the rocks and minerals units. So let's head off one question at the pass before we even get started. Which, if you're like many students have had in the past, and I don't blame you for it, but if you are, first thing you're going to say is, what do I go to learn about rocks? So let's think about that. One, you're enrolled in Earth Science. This is the geology-based course. I mean, there's no way around it, right? We're going to learn some rocks. But what's the real reason why we do this? Why is this part of a state curriculum? Why is it important? And where might this apply in other fields? I would say almost every job has the idea of this lesson involved in it somehow. And that point is that, hey, if I take a peek at all of these, can I start looking at similarities they have? Can I start looking at characteristics they have and maybe then putting them in groups based on those characteristics? If you were to be a baseball scout, you would go watch baseball players and put them in groups based on certain abilities that you need to fill in your roster. If you're an arborist, you're going to put things, you're going to make observations about trees. This bark, this type of leaf, this height makes me think that it's this kind of tree. And then maybe in this area, there's these kinds of trees, and that implies other things. So this is like an across the board skill set of classification, of making observations and putting things in groups based on those observations. I'm sure that the guy across the street over there that's making all that noise with the heavy machinery has to put things in groups as well. I hope that's not interrupting the video too much. So let's think about what we got to do. When we look at these rocks, we're going to have three basic types, all available. The cool thing about this unit, the part that maybe makes it easy, is all of the information's on the reference tables. This is like an everyday use your table. And if you learn to use these tables and you go through the lessons and do it intently, like if you're one of the people that just fast forwards through videos and grabs the highlights, it's going to be a little harder. If you take your time and work your way through these videos and see how to use each one of these, this should be no problem 100s on the test. This is generally the easiest test of the whole year here in Earth Science. Because really all the information's sitting there. All that we've got to do is learn the basics on how these things work, and you're going to be set. All right, so as you may have heard of before, you've got three basic rock types: igneous, metamorphic, and sedimentary. What I did, and I attached this in the Google Classroom, is I made an ESRT where I deleted out all of the other pages except for the three that you need for rocks and minerals. So this page has the rock cycle, and this, we used that last unit, the water speed for particle size. So maybe it's not super handy, but this boulders, cobbles, pebbles, sand, silt, clay as particle sizes still comes up a tiny bit. Then you've got igneous. Let's make my head smaller. That's page 6 of the tables. Again, I deleted 1 through 5. Then you've got the sedimentary table and metamorphic table. It's on page 7. And then I deleted a whole bunch more on the very back of the actual reference tables, page 16. We'll talk about minerals. Okay, minerals being the building blocks of rocks. If I grab a rock here, and you can see all those pink and black bits, those pink and black bits are the minerals that make that rock up. All right, let's try to plow through the three rock types in a very basic sense. Take these notes. You should have this document open, and then I'll give you a couple easy jobs, and we are ready for rocks. So let's talk about them. Let's try to do why is each one of these rocks cool, groovy. All right, I'm going to blow this up. You're going to have to do some shrinking and blowing up of this to be able to type what we'd like. But we're all getting pretty used to Cami. You guys should be good at this by now. Let's start down here with magma, melted rock. All right. In certain places tectonically, we have to kind of accept that tectonics is a thing for the rocks and minerals unit, although we haven't studied it yet. That'll be the beginning of marking period 4. Real short story is the planet has a very, very thin crust on the outside, which is broken up into big chunks. And those big chunks move around and they make stuff happen physically on the surface of the Earth. It's a really thin plate. If you cut an apple in half and look at it from the side, that proportion of the skin to the size of the apple is about appropriate, about correct to scale for how thin our crust is, which is scary. So when those like two pieces of crust, if they go like grinding past each other and shake, we feel that as an earthquake. Tectonically, there are certain places where, because of what's happening that we don't know about yet, but we'll get there, because of what's happening, rock melts. And when it does, we know that hot stuff likes to rise, so it tends to melt its way up through basically like creating its own plumbing to work its way up towards the surface of the earth. Sometimes it doesn't make it. Sometimes it gets part of the way there, goes off into a little bit of a bubble, and cools inside the earth. And there's going to be some important stuff we got to figure out about those when we get to the specifics on igneous rocks. Sometimes it comes shooting right out of holes in the ground, which we call volcanoes. And that's when it comes to like saying, why are igneous rocks cool? The best answer I got is, well, volcanoes. I mean, that's got to be one of the coolest things like that you could witness in the world of rocks. So we're going to call these igneous rocks. Come from, just space this however it works for you. I don't know if I'm nailing it here. Magma, lava. We call it magma below the earth and lava on the surface of the earth. Subtle difference, not a huge concern right now. But yeah, that's them. Igneous, think of ignite, fire. And that's what's where you'll get there. Okay, 1 of 3 down. And again, they're cool because volcanoes. What else can you say? Next, what happens is that, and we just finished this unit. You should be comfortable with this idea that every single day between the hydrosphere, that's all the water on Earth, and the atmosphere, Earth's surface is getting the daylight speed out of it constantly every single day. Every bit of exposed Earth is under attack by those elements and by plant roots and things like that. We talked about all those forms of, let's change colors for our next rock type. We'll go green. Weathering. This should be old news. This breakdown of rock. And once that stuff is broken down, you know what? I want to say a little bit more. Makes sediment. Because once that stuff is broken down, then we have erosion, which is the movement of sediments. And in rivers and due to wind and things like that, where there's active earth science processes happening, is going to keep that sediment moving along, but that energy can't keep up forever. Eventually it ends up in a lower energy environment where it gets dropped off. And those are the most common depositional environment is underwater here on Earth. Deposition, which is drop off of sediments. All right. So if you can grab your pen tool, I'm not saying this is super easy to do. Let's make our ocean a little bigger. But take a stab at it. Let's see how you do. Get yourself down here. Because as sediment washes out into these large bodies of water, it deposits at the bottom, right? And then after that happens, there's more on top. And 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 it keeps going and going and going in these depositional environments, right? So if you're low down on that pile, you're getting squished, just plain old pressure. Some of that pressure is going to pull some of the water out of it, squeeze some of the water out like a sponge. And mineral cements within that water can help take those sediments and glue them together. This whole process, the fancy words, lithification. But at the end of the day, this whole process is what creates layers of sedimentary rock. Now, why are they cool? Some might argue that you can find somebody that will argue that each one of these is the coolest. And maybe I'm going to lean towards the sedimentary people, which the hard rock people would be furious at. But why are sedimentary rocks so cool? Because it's like a book. I mean, if you go down to the Salmon River there in town, where there's the cut from the river eroding down into the bedrock, you're looking at the pages of a book. You're looking at Earth's history layer by layer by layer by layer. The older stuff is on bottom, and younger stuff subsequently landed on top of that, landed on top of that, landed on top of that. And you can literally go pull out a rock, like a page of a book, and look for fossils, look for evidence of what the planet was like at the time that that sediment got laid down. It's written for us. It's there. These natural processes have led to a tale of Pulaski's history in that short little section. And we can find other outcrops that are above it and others that are below it and put together a pretty good history of what's going on here in this planet. Long and short of it, is that too much? Made from sediments, which is like the no duh statement of the year, right? Now, with that and with igneous and with the next one we got to do, yeah, there's a lot more to all of these. We're going to do a lab for each one of these. We're going to do a lab, for the rock cycle to say, how do you tell the difference between all of these? We're going to do a lab for minerals. Oh, the fun we have in store for you guys. The scale of this diagram isn't quite right to let us do the next one. So I usually do like a weird little drawing here, which you can like do or shortcut or whatever you think. If I do like an arrow with a little crookedy thingy like that, that's what you call that, a thingy, and another arrow to say that, hey, I need to say that this is at depth. So like this piece of paper is just too small. If we went down deeper and we got to an area where because of the overburden of all this very heavy rock, the rock that's down here is getting smushed and heated and altered, we get a rock called Metamorphic Rock. If you've heard a metamorphosis, that's a change, caterpillar to butterfly, metamorphosis. Cute little fuzzy gremlin to evil slimely gremlin, that's a metamorphosis. So changed rock from heat / pressure, which you can barely see on that. Metamorphic, changed rock from heat and pressure. Now it's got to get pretty darn hot to actually physically change a rock and like alter the minerals and maybe line them up. If I had ridiculously strong hands, superhuman hands, it'd be like that, right? I'd make it hot. I'd smush the minerals under pressure, and I'd alter what that rock looks like, what the minerals in that rock really are. But one important thing when we get to all this, it's not so hot that it melts, because if it melts, you've gone back into this part of the cycle. You've gone back to melted rock, which is going to create igneous rock. So you can't melt and then go back to a metamorphic. You see what I'm saying? Like if you get hot enough to melt, you create magma. We're in the world of igneous. If you turn it to sediments on the surface of the earth and dump those somewhere to pile up and accumulate, you're in the world of sedimentary. And if you take either one of those two or even another metamorphic and put it under a good amount of heat and pressure at depth within the earth, you end up with changed rock, metamorphic rock. Okay? All right, if you got all that, that's a great job. Great start. I do want it to be on your sheets, though. Please make sure that you're keeping up, which if you're this far in the video, you probably are. Here's your job. You're going to take this document right here, and here's a whole bunch of words that probably look like babbling, right? And we're going to choose some colors, which I probably should have done ahead of time. I'd also like you, if you can, most people have figured this out, make this transparency thing down a little bit. Let's pick 4 colors. Igneous will be red. That's a good color for igneous. I'll have this done. I'll upload this version that has these colored things on there. Sedimentary. How's purple sound? Metamorphic will be green. And then if they are minerals, if these words go with minerals, they'll be yellow. So you'll come down here and highlight according to that key, right? Well, how the heck do I know? I've never heard of any of these words. The purpose of this assignment is that you go to the reference table here and you look around and you just explore. Even if we don't know what it means to be foliated or felsic or mafic or whatever, all those words are on here. I wouldn't have put them on there on that sheet if they weren't on this thing, right? Is felsic the first one? Felsic. So you're going to say, okay, felsic. What does that go with? I look around, and there it is right there. Felsic, that word goes with this reference table, which is the igneous reference table. So then you say, okay, felsic, igneous, that's red. Highlight that in red, and we're good. See what I'm saying? So you'll do that for all those words. By the time that you've done all this, I know it seems like a little bit frustrating and a little silly since you're not necessarily, you don't know what these words are yet. Trust in my methods. We in Pulaski tend to do quite well in the rocks and minerals sections of Regents. Do this to get used to just how those tables are laid out and where some of these crazy words are and all of that. Then we'll attack it one by one and unwrap it all, but it takes some time. This is a good first step. So that's going to be part of the job. Probably another little classwork. And we're on our way. So, yeah, good job. It's exciting to have moved to a new unit. And Rocks is one of my... And someday, this little stop button is going to come up and this video is going to end. Hey, what do you know? All right, folks, thanks a lot. We'll catch you soon.